Hello everyone, welcome to my channel. My name is Israel, and in this video or in this course, I'm going to be teaching you guys Linux. Now, over my years of working as DevOps engineer and as also a lead DevOps engineer, I have come to understand that not all aspect of Linux is needed for you as a DevOps engineer. So in this video or in this course, I will be focusing more on the aspect of Linux that we need as DevOps engineers. So there's not going to be any flaw. I'm not going to bore you with knowledge that you don't need. So this course is purely focused on the aspect of Linux that, pertains to a DevOps engineer. So if you are a beginner, then absolutely this video is for you. Now, this video or this course is going to be a series, and today is the day one of that. So it's going to be the day one of the Linux 101 course for DevOps engineers. Now, in this day one, this is what you're going to learn. Firstly, you're going to learn what is an operating system, what is Linux, and we're going to understand some of the brief histories of Linux and some of the fundamentals. And also, we're going to understand the Linux distributions like Ubuntu, CentOS, Debian, etc. And also, we're also going to understand the difference between these distros. We call them distros. You can also call them distribution, but you can also call them distros. So we're going to understand some of their use cases and all of that. And also, we're also going to understand why DevOps engineers need Linux. Why is Linux such a big deal for a DevOps engineer? So without wasting much of your time, let's jump straight into it. But before that, if you've not followed me or subscribed to my channel, please do well to hit the subscribe button, follow me, and share to people or your mates who need this video. Thank you guys so much, and I really appreciate it. So without wasting much time, let's jump straight into it. So let's understand what makes up an operating system. But before that, let's understand what are some of the other components of a computer. Now, in a computer, we have the hardware and the software. Now, the hardware is what you see physically and what you can touch. In other words, these are the physical components of the computer. So we have, we have CPU, we have RAM, we have storage, we have disk. All these are the hardware of the computer. And also, we also have I/O devices like, your mouse, your printer, your keyboard, and all of that. All these are I/O devices, which is known as input and output device. These are what you use to input, programs, to run commands on your operating system. They're also what you use to interact with, your operating system as well. Now, before we understand the importance of, the operating system, and also in order for you to appreciate the importance of the operating system, let's understand how it was before operating system. Now, before the adoption of an operating system, what happened is that when you have a software developer who is writing, they're writing an application or they're developing an application. Now, they are writing the application in two parts. Now, the first one is the application itself, which can be your Facebook, your WhatsApp. I'm just using this example. So your Facebook, your WhatsApp, Instagram, and all of that. Now, the other aspect is you writing another code that enables your application to interact with the hardware. Now, mind you, whatever application or process or program that you have running on your computer, they all need access to, memory. They need access to storage. They need access to, network and all of that. So how do you, allow, or how do you enable this application to have access to the hardware? Now, then whenever you're writing your application, you see that the application goes straight to the hardware. You need to write that code, that logic for that application to communicate with the hardware. Let's say, for instance, Chrome need access to CPU, RAM, and storage. So on top of the application code that you've written for Chrome, you also need to add that additional layer of program that will enable this Chrome to talk to CPU, to talk to the RAM, to talk to the network interface and all of that. And this was a very huge barrier for software engineers, because writing the application code itself is already a huge task, and then you are adding another layer of responsibility by giving them by allowing them to write an application that interact with the hardware. Now, as you can see from here, it is really messy. Now, it's really messy. So every application needs to have their own logic on how to interact with the hardware. And mind you, since all these applications are interacting with the hardware, there can be conflict whereby one application is using or is requesting more of some of these hardware resources, or one of these processes, or one of these applications is, laying hold or hijacking or seizing one of the hardware. Like, for instance, this Chrome might be holding the CPU and not releasing it to other processes. So as you can see, there can be competition between all these applications for who have access to some of this hardware. And on top of that, it is a huge security risk, because if one application gets compromised, the whole hardware or the whole application can be as well compromised. So because of all these challenges, limitations and all of that, that is where the operating system came to save the day. So it was born out of the frustration of, how to enable application to interact with the hardware resource. Now, with the invent of, with the adoption of operating system, we now have this setting. Now, previously, the application talks directly to the hardware. But as you can see from here, the application needs to communicate with the operating system, and then the operating system relays that information or that request to the hardware. Now, before we go into some of the nitty-gritty of an operating system, now, what is an operating system? Now, an operating system is a software program that sits in between the applications, the user application, and the hardware. Now, the operating system is what coordinates the different processes running on your application. It helps to coordinate your hardwares, your CPU, your RAM. It helps to manage them, manage all of these effectively. Now, the hardware itself cannot manage itself. So it is the duty of the operating system to manage, how to allocate all these hardware to processes or program running on your computer. Now, as you can see, we have the application at the top, which is running on the user namespace, and then we have the hardware. Now, in between these two layers, we have an intermediate layer, which is the operating system. And now for the application, or for your application running on the user namespace to, communicate with the operating system, they make syscall straight to the kernel or to the operating system, and then the operating system relays it, to the hardware, gets whatever they are requesting for, and sends it back to the operating system. Now, this solves a lot of problem, because the software developers need to only focus on what really matters, which is the application. They don't need to understand, they don't need to implement logic of how this application, writes to a disk or request memory or request RAM, whatever they want to do. They just simply communicate directly with the operating system, and the operating system does the heavy lifting for them. Now, let's go a little bit deep into the operating system. As you can see, the operating system has, layers. We have the OS application layer, which sits on top, and we also have the kernel. Now, the kernel is the heart of the operating system. It is the core of the operating system. When I say the operating system manages CPU, manages processes, memories, device, network, IO device and all of that, that function is being done by the kernel itself. So it is kernel that does all this. And because it is under the operating system, that's why I generalize it by saying that it is the operating system that does all of that. So let's understand the function of the operating system. Now here are some of the function of the operating system. The first one is resource management and allocation. Like I said earlier, when you have different processes. Now, what is a process? A process is, a unit of a program that is running on your computer. When you open your Chrome, you open your VS Code, underneath or in the background, a process has been spun up. So when you open a Chrome, it starts a process on your computer. And that process needs memory. That process needs CPU. That process needs, some kind of storage. Now, it is the duty of the operating system to effectively manage these, processes, allocate resources to them, based on what they need. So the operating system does that, by managing the resources and also allocating various resources to your processes. Secondly is process isolation and management. Like I said earlier, they help to isolate processes and also manage them. Now, when you have more than one process running on your computer, now without the OS, like I said before, it can get to a point where these processes can conflict and also, compete with each other for a specific resource. But the OS, comes in to save the day by, managing these processes. So one process does not override another process. And also for storage management. Now, when your process or your program or your application need to write to the disk, maybe your program needs to save some data. So it is the duty of the OS to manage this, to, make the request to the hardware and also relay back the response to your process. It also helps in file system management and also managing your IO devices. So it is duty of the operating system to manage your input and output device by using device driver. And also for security and networking. So it is the operating system that enforces, permissions on your files. Maybe you don't want a specific file to be accessed by a specific process or a program. So it is the operating system that does this enforcement at that level. So these are some of the functions of the OS. And in brief summary, I need you to understand that an operating system is that application program, that helps to coordinate the hardware resources and also allocate these resources to processes or program or application that need access to them. So instead of the application or the process talking directly with the hardware, they simply release or they simply communicate with the operating system, and the operating system does the heavy lifting by, attending to their request and also relaying that information to the hardware. So as you can see, the operating system is the brain behind your computer. Without the operating system, your computer can be useless because there's going to be different different competition between processes. So an operating system is one of the basics fundamentals of a computer. Also, we have different operating systems. We have Windows operating system owned by Microsoft. We have Mac OS, which is owned by Apple. And also we also have the Linux operating system, which is an open source operating system. Now, as you can see, it is open source because it has, so many contributors, people who are contributing to it. And also it is not just for one person. So it is purely free and anybody can download it from the internet and install it on their computer. completely for free. So let's understand what Linux is, because I know many people have come across the buzzword Linux and they are wondering, what is Linux? Why is Linux? Why is that name so common amongst DevOps engineers? Now, in this video, I will tell you why. Now, what is Linux? Linux is an open source, it is free and open source operating system. Like I said earlier, it is open source, meaning anybody can contribute to the code. And also it is free, so meaning you don't need to pay for it. So it's totally free, unlike Windows where you need to install it and then purchase a license to use it. And also it is based on the Unix architecture and principle. Now, in the early days, when software engineers were, they are trying to write the application, they are struggling to write the application and also the code for the application to interact with the hardware. Unix was one of those operating systems that was born as a result of that frustration. So as you can see, Linux was, built from the Unix architecture. And also this is the reason why you see that sometimes most of the commands running on Linux are similar to macOS. That is because macOS and Linux, they were, extracted from the Unix architecture. So now the fact that Linux is a free and open source operating system makes it highly secure, stable, and highly customizable. Now, what happened is that when an operating system is open source, meaning everybody can see what is happening in the code, and it is very difficult for something it is very impossible or difficult for an insecure or for a vulnerability to slip through the eyes of all the contributors. So if there's any vulnerabilities in the code, it is very easy for anybody to see it because it is open source. You have multiple eyes watching and also contributing to it. And now the reason why so many companies are adopting Linux is because, number one, it is secure. Number two, it is free. Number three, it is highly customizable. I don't know what other operating system does this for free. We see an operating system that is free, customizable, and is highly secure. It is no brainer that every company would want to go for this kind of operating system because obviously who don't want the best, and companies, they don't like paying for things. Sorry to say that because, in as much as the company are trying to provide value, they also want to cut costs. And I think Linux is, the best choice, and it is, it is scalable as well. And lastly, Linux powers 80 to 90% of the world servers. Your cloud environment, AWS, are running on Linux. Most of the VMs are Linux-based machines. Your smartphones, like your Android phone, is running on Linux kernel. Your routers, your switches, your networking device are all Linux based. So as you can see, Linux is almost everywhere. Your IO devices all are running on Linux operating system. So as you can see, Linux is, is massive. It's really, really massive. Let's take a look at some of the brief history of Linux. So Linux was developed by Linus Torvald, and he was the first contributor to the Linux open source. And Linux is the biggest open source project we have in the world. You can check it on Google. Linux is the biggest, is the one that has the most user, or it's the one that has the most contributors across the globe. So the first contributor, the person who invented Linux is Linus Torvalds. And it's the early adoption supported by global open source community, and also combined with GNU tools, it forms a complete operating system. Like it forms are often known as the GNU Linux. And in 2000, it gained traction in data centers, academia, and enterprise servers. So at this point, Linux in 2000, Linux started gaining traction. So companies started seeing, the beauty and the securities and all of that in Linux, and then now they started adopting Linux. And today, Linux dominates the world. It dominates the cloud, the DevOps tooling, containers, web hostings, and all of that. All these are what makes Linux such a powerful operating system when compared with other operating systems. And that is why you need it as a DevOps engineer. Now, let's have a look at the Linux operating system in detail. Now, the Linux operating system, like I said earlier, has different layers, different components. So let's start with the first one, the Linux kernel. Now, like I said earlier, the Linux kernel is the heart. The Linux kernel is the heart of the operating system. It is the core of the operating system. It is the brain behind the operating system. It is what connects the hardware, which is your computer CPU, your RAM, your storage, and all of that, with the software, which is your application that runs on top of the OS. So in the previous diagram, when I drew how your software, which is your application, interact with the operating system, they are interacting with this Linux kernel layer of the operating system. Now let's look at some of the core responsibilities of the Linux operating or the Linux kernel. Now, number one, process management. Now it is the Linux kernel that starts, and schedule programs in your computer. Like I said earlier, program can also be can also be called processes. And also, I've also told you that whenever you click on your Chrome, when you open your Chrome browser, it spins up a process running in the background. Now, that process needs CPU. It needs CPU for, calculations, to process stuff and all of that. Now, it is duty of the kernel to, start that process. And secondly, memory utilization. Now, it is the Linux kernel, that helps to control how program, interact with memories. Now, you have 3 to 4 processes running on your computer. It is the duty of the kernel to allocate these memories to these different programs efficiently. And also, it also have the intelligence to see that when one process is consuming less and one program have idle access, it simply, allocate that extra memory to another process that needs, intense memory. Let's say, for instance, you have a Chrome, you also have another applications running or processes running on your computer, and a memory has been allocated to one process, and maybe that process is not using, it's not utilizing all those memory allocated to it. Now, the operating system has that intelligence and that functionality to see that, okay, this application is not using, the expected amount of resources. Then it can extract, it can take away that memory and assign it to another application that needs it. So as you can see, the kernel, is the brain that does the heavy lifting. It is what understands, what different processes need at that point in time. And also sometimes, as you know, a computer that has one CPU can only process, it means it processes one application at a time. So it is the operating system that swaps this. Maybe an application needs memory at this time. It is the application, it is the operating system that assign this CPU to different processes, at each time intervals. So as you can see, the Linux kernel is the brain behind everything. Also, it also helps in device management. It is what talks to the hardware through drivers. It talks to the hardwares like your your browser, your keyboard, your disk, your network card, and all of that. All these, are managed by the kernel. And also your file system, your file system is like, have files, have different how different files are being stored on your computer. So it is also it's also the function of the operating system or the Linux kernel, to manage this, allow programs to write to these files. Maybe your program or your application needs read and write access to the disk. It is the Linux kernel that does this. It is what allow that open, read, and all of that. And also security and permission. Now remember that security is very important. Now it is the kernel that enforces the security. Maybe a program doesn't need to, read to a particular file. So it is the kernel that enforces this restriction at that level. And also networking, it is operating system that, gets your packet when you send a request to your computer or your computer accepts a request. It is the operating system that does, the management of that packet, down to the application layer. So it's handle traffic like, HTTP, TCP, IP, and all of that. So these are some of the, functions of the kernel itself. So on top of that, we have the system utilities. Now, what are system utilities? Now, system utilities are, there are small programs. That's how I kind of think of it. There are small programs, or tools that helps you to interact with, manage, and also control the Linux operating system. Now, these are utilities that helps you to move around, that helps you to interact with the operating system. Maybe you need to copy a file from one place to another. They give you that, commands, that command on how to move file. So example of system utilities are the MV, CP, MKDRO, PS, top, CP, and all of that. All these are system utilities, and they are available for users who have access to the Linux machine or Linux operating system. Most of these utilities they are stored on some of these directly on the file system. So we have them as /bin, /sbin, /userbin, /sbin. Now, in my subsequent video, we're going to be exploring these file system in great details. But in this video, it's just like an overview. So yeah, so these are some of the system utilities. So like I said, system utilities are program or tools that helps you to interact with, it helps you to interact with, manages, and control the Linux operating system. So on top of the system utilities, we also have the system libraries. Now, what are the system libraries? So system libraries are a collection of pre-written program or code that program can use to do common tasks like printing text, reading files, or talking to the network. So they are simply collection of, programs or written code that, application needs. For instance, if you have 3-4 application that needs to, read to a file. Now, instead of them, writing or adding that functionality of code on how to interact with those files, they simply utilizes the libraries that are already available on the operating system, and they're using that library to make an API call to the hardware to get, maybe you're trying to read a file. So that is what system library does. So we have, massive system libraries on the Linux operating system. Now, what we have the G library by C, we have the libc and all of that, and they are all stored on the /lib/lib64/user/lib on the operating system. Another way I kind of think of the system libraries are, I kind of take on them like, reusable building blocks for softwares. Now, instead of every application writing its own, let's say, open a file function, it uses the library that they already know how to do it. So yeah, so when you have that application, they simply use that library to make that call and to get things done. And on top of that, we now have the CLI and the UEI. Now, this layer is how we interact with the operating system. Now, the CLI is known as the command line interface. It is a programmatic access to the operating system. This is where you run commands like your env, your cp, mkdir. This is where you run that command to interact with the operating system. And the GUI is known as the graphical user interface. It is how it is how you also communicate with the OS. So instead of you running commands, you simply use GUI by clicking the button or going to the file. So obviously, practically, GUI is what is interacting with your computer at a graphical level, just like in your current computer, how you move files, what you can see, and all of that, or whatever you do at that level is you are simply interacting with the GUI of the operating system. So how does users and application, communicate with the hardware or the operating system? Remember, in a computer, there are two major parties that are using a system. Now, number one is user, which are humans, me and you. You watching this video, you are interacting with the operating system by clicking a button on YouTube and all of that. So the second user are application, which are your programs, your YouTube app, your Apple Play Store, your Instagram, your Twitter, and all of that. All these are applications that are interacting with the operating system. Now you see the human interact with the shell. It can be CLI, GUI, or whatever the user want to interact. They make syscall, like I explained. They make a syscall to the kernel, and then the kernel, relays that information to the hardware. So the hardware conversely sends back the response to the kernel, to the, from the syscall back to what you can see. So that's it. So this is like the flow of execution on how users can request, a particular resource from the hardware. And at the application level, obviously applications are not human, so they cannot click the UI, they cannot run commands. So what application does is that, remember I talked about the libraries, which are a group of primitive code that programs uses to do common tasks. So the application makes an API call or uses the library, and then that request goes through to the kernel via the syscall system calls and then to the hardware. Now this is like a high level overview of how these two people or these two users communicate with the hardware. So that being said, let's understand the different Linux distributions. We call them Linux distro. Now, why do we have so many Linux distro? Now, remember I told you that, the Linux kernel is highly customizable. Like you can add so many features and all of that. You can clone the source code, add whatever features you want to add on top of the core functionality, and then, build it, remote it to suit your own use case. Now, this is what so many companies are doing. So many companies takes the kernel, which is the core building block for the operating system. They add more functionality to it and use it to produce their own version of the Linux operating system. Now, that is what is known as Linux distribution. Now, understand that all Linux distribution, have the same Linux kernel. Now, obviously, there are so many things that has been added to it, like some of the GUI, some of the utilities, some utilities are added, some are removed, and all of that. But the kernel remains the same, which is the Linux kernel. Now, the first one is Ubuntu, which is owned by Canonical. So Canonical added more functionality to the Linux kernel. They added more stuff to it, and then they produced their own version of that operating system, which is known as the Ubuntu Linux operating system. So the second one is Debian, which is owned by the Debian project. So this is not owned by any company. It is open source driven, so anybody can contribute to it. Now, don't get it wrong. Now, Linux itself, the Linux kernel itself is open source, meaning nobody owns it. So everybody are contributing to it. However, some of the distros are not open source. For instance, the Ubuntu by Canonical is open source, though it is open source. It means that Canonical took the open source Linux, add more functionality to it to produce their own operating system, which is the Ubuntu operating system. But mind you, all of these distro have the same kernel. So they are born from the same kernel, but they can have different flavors, which is known as Linux distribution. That is how we have now have Debian. But Debian is also free. It means that it is cloned from the Linux kernel repository, which is the open source one, and then more things are added to it. However, it is also free by anybody, meaning that the cloned version and what has been added to it is also being maintained by another open source. And the open source community behind it is known as the Debian project, so it has like a huge community. And thirdly, we have Fedora, owned by Red Hat. Now, Fedora is owned by the company Red Hat. So Red Hat are another company that added more functionality to the Linux kernel and produced their own flavor or their own distro of the Linux operating system. We also have CentOS by Red Hat. There are a lot of them. There are a lot of Linux distribution, and all these have their own use cases. Some of them are specific to some use cases. Some of them are specific to another use case. We also have Arch Linux. We have like different kinds of. So some of their use cases are Ubuntu is best for beginners like DevOps, cloud, and general purpose servers. It is well documented, and also it is one of the most popular on cloud servers and all of that. And it is great for DevOps tools like Kubernetes, Docker, Terraform, and all of that. And it has like a massive community support. And also we have Debian. Debian is a stability focused server. When you need a server that is stable, then you can go for Debian. Debian, they have like stable support for 5 years, unlike Ubuntu that does their own for 2 years interval, And also it will interest you to know that even Ubuntu was an extract from Debian as well. Yeah. It's an extract from Debian, and it is more advanced for users, and also it is super stable. It has lower release cycle, like I said earlier, every 5 years, I think. And also, you can use it to build your own custom, operating system as well. We have Fedora, which is by Red Hat. These are enterprise, Linux operating system that are used by enterprise. They have frequent updates and all of that. It is great for developers and people who want to make modern kernel tools. And, it is nice as well. And also we have CentOS, like the two of them are from Red Hat. So, you can have a read about it. So what are some of the common differences between, some of these Linux distro? The first one is one of the major difference, or one of the key difference between what differentiates one Linux distribution from another. One of them is a package manager. Some of them tend to have different package manager, like Debian and Ubuntu uses the apt package manager, and also the Fedora one uses Yum as a package manager. Now, don't get confused about what package manager is. We're going to explore that in our subsequent videos. So yeah, just follow me. And also target use audience. Like I said earlier, Debian is used for, Ubuntu is beginner friendly. And I think that's what we want to be using for the rest of this course. It is purely focused on, user experience, like my current machine is running on Ubuntu, yeah. So it is used for, learning for day-to-day tasks. And as a DevOps engineer, you'll be using mostly Ubuntu for, server administration or on your local computer. And also use cases Debian for stability. Obviously, your production workload, your production server should be running on Debian operating system. So these are some of the target users, and also Red Hat are majorly focused on enterprise level. So yeah, some of the use cases, and also device file structures and tools. Like I explained earlier, some of the file structure differs, and some of the utilities, like when some company wants to create their own operating system from that kernel, they simply add more functionality to it, or they take away some functionalities. So as such, it is obviously it is obvious that some of the functionality might differ, like some of the commands, some of the utilities might be different across some of the operating some of the distros. And also community versus enterprise support, like Ubuntu has enterprise support, I think. And also Debian has it has like a community support as well. But Ubuntu has a community support. It also had like an enterprise support as well. But then obviously everybody wants to go for the free version. Yeah, so these are some of the key difference. There are a lot of them, but these are the ones that I think are important and I think you should know. If you need more reading, you can go online and check some of the difference between the Linux distros. And lastly, before we go, let's understand why DevOps engineer need Linux. Now, this is the very vital question. Why do we need Linux? Why do we need Linux as DevOps engineers? Now, the first one is Linux powers the cloud. From virtualization to VMs and all of that, it is purely on Linux. Your EC2 instance running on your AWS is from Linux. Like Linux literally, powers almost everything in the cloud. Your switches, your internet gateway, all of those hardwares are powered by the Linux. So as you can see, Linux is, the powerhouse behind massive IT infrastructures. And also, secondly, containers and Kubernetes are Linux based. Now, you must have come across the term containers and Kubernetes. All these are Linux based. Initially, when Kubernetes was invented, it was purely focused on Linux operating system. Where I think as time, as time begins to go, we started seeing integration with the Windows operating system and also Mac OS. So yeah, containers are based. Containers and Kubernetes are Linux based. And thirdly, it is the industrial standard for hosting web application. Web applications are hosted on Linux server. We have web servers like Apache, Nginx, and all of that. All these applications are hosted on the Linux operating system. Nginx itself is running on Linux operating system. So as you can see, Linux is everything. But with the rise of technology, we started moving towards the container side of things. I started seeing like containers and all of that. In as much as that, all these are also running on Linux operating system. Now, your CI/CD pipelines for DevOps engineer is running on Linux. Whatever commands you input into your CI/CD pipeline to build, test, and all of that are all Linux command. So as you can see, Linux is almost everything. Sorry, Linux power the card. I've said that before. Sorry, that's a mistake. And lastly, automation configuration tools target Linux. Good. Your Terraform runs on Linux. Your Ansibles, all these are purely focused on Linux. Like your Ansible is running on Linux. So as you can see, Linux is almost everywhere. Like as a DevOps engineer, you cannot be a DevOps engineer without understanding Linux. So because of that, Linux is very, very vital for you as a DevOps engineer. So this is the end of the video, and I hope you've learned one or two from the Linux course. Like I said earlier, this is an introductory class, and my subsequent video, we're gonna understand how to install Linux. different ways to install Linux, and I will walk you through how to set up Linux on your local environment. So thank you guys for watching this video till the end. It means a lot to me. And if you find this video useful, please do well to subscribe, comment, and also share with somebody who needs it. Thank you, and I'll see you in the next video.